My name is Drew Bansel. I'm with InfoChimps.org. We're a local Austin startup. Woo! Yay! All right, great. We're a data marketplace. If you have data to share, we'll host it online for free. We can't hear me. Okay. We are an Austin startup, and if you have data to share, we'll put it up for free online. If you have data to sell, put it on our site. Let us connect you with more buyers. We're hosting this event tonight because we really, really want to talk to businesses out there in this emerging data ecosystem that have data coming in and data coming out. We want to talk to you about how to make money off of that transformation. And second, we've noticed a lot of new companies coming into this system, a lot of conversations that have started, and we're really hoping that tonight can be an opportunity to bring a lot of those disparate threads together and start some new conversations. But before I sort of describe what we're going to get into, let me give some thanks where they're due. Thank you for our sponsors. First of all, got to thank Rackspace. Thank you, guys. Thank you so much. Getting it filmed for us. Rackspace, another great Texas-based company. If you have cloud storage or cloud computing needs, please check them out, especially if you require fanatical support. Wolfram Alpha, another great sponsor, another amazing example of the things that you can do when you have access to a large amount of structured data. I got to thank Factual.com. They're another great online spot for open data. They have this great embeddable API so developers can share data online. Got to thank No More. They haven't launched yet, but they're a social media dashboard, help you get some analytics, information about the social networks that you're following. I also, and honestly this is not in the script, I have to ask some personal thanks to Royal from JDI, to Brian Connor, our very talented and handsome designer in the back. As well as to Adam from the Web 2.0 show. Thank you a lot, guys. Without your work, this wouldn't come off. Whoa.
Hold the mic regular, we'll do that. Yeah.
Hold the mic regular, thank you. All right, so let me sort of describe quickly tonight's main event as it is, which we're calling the Non-Relational Database Smackdown, a head-to-head event between three no introduction needed contenders in their field. We've got Stu Hood from the Cassandra Project, as well as Rackspace. Thank you, Stu. Yeah, that's right. Weighing in at over 100 terabytes. And then there's Jan Lenhardt from CouchDB. We've got Wynn Netherland from MongoDB as well. There's some bookies in the back taking bets. I suggest everybody get over there quickly. And I'm going to hand the mic over in just a second to these guys. They're going to start whatever it is. Physical battle, mostly. Yeah, mostly physical battle. Okay, great. And then after that, at about 8 o'clock, we're going to open it up a little bit more informally. We're going to have a bunch of birds of a feather sessions all around here on the upper level of Opal Divines. And I'll come on back on the mic around 8 o'clock and introduce all the speakers there and give you guys where to go. My God, I really shouldn't talk anymore. Everyone, enjoy the Non-Relational Database Smackdown.
Hello? Okay, this mic is working too. I also wanted to point out that Werner Vogels is here, and he may be participating in a few of these little battles that we bring up here. Excellent. So first of all, definitely ask any questions that you have immediately. Hopefully they'll be relevant, but anything that you're curious about. So right now we have Cassandra, MongoDB, and CouchDB represented. Everyone's claiming that they're NoSQL. Nobody really knows what the exact definition of NoSQL is. It means many different things. It means data models. It means replication. It means, what else? Scaling. So first up, let's talk a little bit about the data model. So Cassandra has a really interesting data model that allows massively wide rows. And we're all document stores, right? So what do you guys think about huge documents?
Define huge.
Huge, like as large as a machine can fit.
They're awesome.
I guess the definition of a document differs then in Cassandra and CouchDB. I don't know that much about Cassandra, but CouchDB can handle big documents, but we tend to think of them as small items, small entities that you handle individually.
I believe Mongo's got a 4 gig per document row limit, if I'm... not 4 gig, 4 meg. No, 4 gig. MongoDB, sorry. MongoDB, right. Right, 4 backs.
Okay, and so everyone, all these other competitors use JSON and kind of are untyped. I don't like that. I don't like that they're untyped. Because you can do massively interesting things if you have typed data. It might be sorted, So you can slice little pieces out of it. That's something that Cassandra provides. So if you have a document and it allows it to grow large, because you might want to get just a little piece of your document out.
Mongo actually uses the BSON spec, so it is pseudo-typed at the file system level. So it's got it's not just strings in the database. You have ints, you have other database types, and you can even store files in the file system. GridFS.
Yeah, CouchDB uses JSON. It does have a bunch of data types. The nice thing about JSON is it's a subset of all the programming language that we're using. It's the lowest common denominator that everybody can serialize objects into in Exchange. So I can have a Java object and serialize into JSON, load it up in Python, and can just work with it without having like thousands of lines of code who does some object translation between some arcane format and something else. So JSON is really, really good for data interchange.
Slow!
What? Oh, so he says it's slow. So Bobby Polito from the Python community wrote a JSON compiler, a JSON module for Python, which is actually faster than the protocol buffers Google claims are so fast. So shut up.
All right. So I believe we disagree on typed, and that's fine with me.
I won't add to the typed. The web is not really typed, and people who are using the web are usually not, I hope most of them are not computer scientists, like sorry to all the computer scientists and me, but you should, it's great that you use the web, but the web is something that enables everybody to share data or to express themselves in some way, and having them to teach about data types is really just like, it's just an arcane artifact of programming. They shouldn't think about how do I store arrays and objects and stuff. They should just stuff whatever they have into a database. They should not think about it. So
I would hope that the people that are developing web applications are computer scientists, but maybe not. I don't know.
There shouldn't be. So there was an argument yesterday, I heard, I guess, that the iPhone App Store has about over 100,000 applications on it, and when GeoCities was shut down, it had over 100,000 websites on it. So it's a different magnitude of scale if you let everybody participate in the open web. So you definitely do want to have everybody who has an interest in doing web stuff and not restricted to the getting it right computer sciences type, because I'm really bored of all the stuff we come up with, and the amateurs who really have no clue what everything is about do the real cool and interesting applications.
That's a lot of crap.
Awesome.
Yeah, let me explain why. So how many programming languages do you know that are completely untyped, except for Perl? Yeah, so everybody that's developing applications actually has types.
Right.
And suddenly you go to the database and all your types disappear.
Yeah. No, that's not true. JSON defines types, you can do that, but you don't have to worry about as much as if you're you don't have to go up front and define, okay, this, I will need an array of integers to store whatever list I'm having. You don't have to think about that much. It's easier for a programmer to do it naturally, and for a non-programmer even more.
Yeah, but you force everybody to rewrite all their programs with these things in mind.
So
no, well, that's a lot of work. There seem to be quite a few programs out there. GeoCities exist, yeah, and all these other things. So what about this compatibility stuff? Why do you guys force, everybody to rewrite all their applications? I'm just playing devil's advocate here. Right?
No, absolutely. Well, so also Hadoop is completely unstructured by default, right? So you throw anything in it and then you process it. You can do something similar with CouchDB. So I don't know why I'm defending CouchDB, but just want to point that out. Type doesn't always win, but okay.
Well, so there's a lot of, I think, for many of these things going, it's not actually about type. It also, when you look at consistency models and things like that, where traditional database applications are used to a very different model. So you either have to rewrite your applications, fixing according to the new model, whether it's typed or whether it's consistency model or other things around it. Suddenly you force everybody to rethink. Now that may be a good thing, yeah, but it definitely hurts adoption.
Yeah, so let's talk about consistency really quickly. Let's talk about the different models. Cassandra has kind of a peer-to-peer model that comes from Werner's brainchild, Dynamo, where any node can accept a write, and then if enough nodes have accepted the write, then the write succeeds. Otherwise, it doesn't. And at read time, you resolve all that. I don't know how I feel about the CouchDB and Mongo models. I mean, Mongo hasn't actually figured that part out, right? I mean,
That's right. There's a 2-second delay before you actually come into the database. Is that what you're talking about?
No, so I believe Mongo is still master-slave type replication.
Sure, sure. And I must admit, core committers to these projects, and I'm just a Mongo fanboy. I used to be a Microsoft fanboy.
Uh-oh.
But the M word. Define a little bit what you're talking about. See if I can define it just as an end user.
So if you have a data center in Washington and you have another data center in California, you can do a write in one of those data centers, and even if the other data center is down, depending on your tunables, you can still succeed that write, because no one of those nodes is actually responsible at a given time. Like it's not, there's no one dedicated to a particular key.
Right, and in this case, advantage Cassandra, but I would argue in most applications that's not needed.
It's not actually the whole consistency model, the eventual consistency model doesn't come from the fact that this is something that you want at the application level. It is basically abstractions from the implementation leaking up. The fact that there's two reasons for replication. Either you do it for gaining fault tolerance, or you do it for getting a higher level of concurrency so you can get better read throughput or write throughput or whatever. For those two reasons you have to replicate. If you have to replicate, you have to make a decision, do I write to all replicas and guarantee to write to all replicas such that my reads are always consistent? That might not be a well-performant issue, because at writes, you get a huge cost, and especially if you cannot get your quorum, you may have to fail your writes. And there's a number of applications where that may not be truthful, where that may not be useful for. So these are things that are actually leaking up from the implementation through the APIs. If everybody could get a choice, everybody would want strong consistency. It is just that with strong consistency means that you have to take a lot of other trade-offs. The main one being not being able to get much write throughput, and the other one is being that there's a number of failure scenarios in which you will be dead in order.
So are you saying that Dynamo wasn't user-friendly?
No, absolutely not. No, actually. So there's a range of things. I think so. Dynamo is sort of one of the systems that predates a number of these, and where we made consistency models explicit. It's not that we were the first ones to offer an eventually consistent system. I think actually most relational databases give you eventual consistency, you just don't know it. Mainly because if you use replication in a traditional relational database, like one of the commercial ones, there's a delay when the logs are being shipped, and if you read from the slave, you do not get the consistency. There's always a window. So but okay, so why wasn't Dynamo user-friendly? Not only for the consistency level, but also, for example, because you had to have the key if you came to the database. There's no way to do a list to figure out what are my keys. So you have to have a key. And the key normally comes from somewhere else. For example, from a customer database, where we developed. So when we developed Dynamo, it was to support shopping carts. That was one of the use cases. So that meant you went to the database, you went to the storage system, and you already had a key. And that's why, for example, S3 is a user-friendly key value storage system, but Dynamo actually isn't that much user-friendly. With S3 you can do a list, you can do a prefix list on what are my keys and then find things out. That stuff, for example, that's not in what's the name of that one?
Isn't S3 built on Dynamo?
What?
Isn't S3 built on Dynamo?
No comment.
Damn it. Someone might have unplugged it.
No, so
Someone might have kicked the plug out over there. Uh-oh.
waiting for it. So, so the answer is no, because if you would be an engineer, if you'd be a developer, you would know that if you have to do a list operator on top of this, that's a completely different internal architecture. So is Dynamo used and Dynamo principles used throughout all of these systems in Amazon where you have to get enormous scale? Yes. Where the system in itself, as we described, it was mainly built for the shopping cart first. But all of these things consist of modules that are being reused throughout the whole company. It's more the principles that matter than the actual implementation.
So
yeah.
I would say that Cassandra is actually a little bit more user-friendly in that case because
Absolutely.
we're not using hashing in order to determine where a key lives. So you can actually do those list operations. You can basically treat it like you would Bigtable from Google and get a list of all of your keys. I imagine you can do that with the competitors, but Cassandra's implementation is better.
So I like that you guys all focus on the big data problem on the massive scale and on all the websites that have these problems, which are like 7. CouchDB is more like the personal database, something that you can use for whatever you want to do. It doesn't force you to think in these big to have these big thoughts. But if you start out small, CouchDB allows you to grow gradually with whatever usage pattern you have. So I think these guys are building Ferraris and dragstars, so we are building a Honda Accord of databases that everybody can use, but can get along with for a long, long time.
Absolutely, absolutely, and you know, there's a reason that couch rhymes with ouch. You know, anybody that's used Mongo coming from CouchDB, it's just night and day as far as the ease of use and getting set up, getting the server installed, finding wrappers for your language of choice. And suddenly, you know, I don't have to know what I'm going to ask for up front. It reminds me of the Seinfeld episode when Kramer's doing the movie phone and he says, "Why don't you just tell me the movie you want to watch," right? It's the same thing with your views up front. You have to materialize these up front, but with Mongo, you know, I can just select on the fly.
You have indexes magically appear with no performance hit?
Well, indexes are one thing, right? But views are something totally different, right? So when I set an index, yeah, it takes effect for that index to kick in, right? It takes time for it, right?
Nobody can cheat with
right,
that.
but I can get around it if I have a low edge case where I need to do a query. With Couch, I have to know what that view is.
You can have ad hoc queries.
Yeah, but realistically, anything beyond, you know, dynamic and Couch just, in my own experience, just haven't been, you know, it's like oil and water.
Oh, you should try newer versions then.
Okay, maybe I need to upgrade.
Right.
So let me tell you about all of these guys suck. Yeah. Yes. Because you should not run your own database. Yeah, that time is past. These guys force you to run your own database, to manage replication, to go dive deep into that. You should. All of this stuff should be a service. How can you know?
How do you, the cloud is awesome, but what do you do if your DSL provider craps out? What do you do when you're the 3Gs now? What if you're on AT&T and you have no more coverage? How do you reach the cloud? You're dead in the water with a really great cloud that you have that nobody can reach.
You go to a bar and you have a few beers, you come back and you
exactly, and your customers and your customers will leave you left and right if you're offline.
Well, you know, given that we've been doing this for a while, I think our customers, I kind of have an idea what customers do in this particular case.
But again, you're one of the 7 sites who.
No. But what is more, like if you aggregate all these customers that we have, whether you have S3, SimpleDB, you know, EBS, and all the other services, you should no longer. I mean, these guys, you are wasting your time. You know, and I love it. You know, this stuff. I really love this data stuff and these databases. I would build 10 more dynamos. Because it is really, really cool. But you're not solving your customers' problems.
Exactly.
Because you're forcing them to do a lot of operational skills.
I agree with you wholeheartedly. Awesome. You shouldn't. People who use databases shouldn't use. We want to use stuff. They shouldn't think about the database as something they would use. Part of the thing we're doing is abstracting the database away to build very, very cool applications and getting CouchDB into all the deployments you could think of that when you want to build something, it's already there and you can just use it. You don't have to think about it. Like my mom should be able to run a CouchDB server without knowing that she runs a CouchDB server. That's the thing we're trying to do. You should not run a database. That's nothing you would ever want to do.
Remember, guys, if you guys have any questions, just throw up a hand. I mean, I'm sure you have comments.
We'll shut you up real quick, but there.
Also, so the comment on the 7 biggest sites, like, don't you guys want to be the next biggest site? Or you want to be the #1 site? So why would you build?
Actually, I would like to really argue against the 7 biggest sites. If I look at the amount of data, and I mean everybody here, is because you all think about big data, right? That's why we're here. And how many of you work not for the biggest 7 sites? I think most of you, don't you? Yeah? Yeah. So there's tons of data out there. Everybody has his big data. With the time where small data sets were normal, I mean, everybody has petabytes data sets, and that's only the start of it.
It's also a control thing. if Amazon, if Google, if Apple, if all these people own all your data, Facebook for example, they own all your data, they own all the URLs. The web wasn't meant to be a couple of big silos. People should be in control of their own data. They should be able to use their own data as they fit. They should be able to put it under the URLs they control instead of being under the whatever these guys are doing to screw them over. It's a big privacy issue. It's another. Oh, it definitely is. There's a bunch of privacy laws in Germany that I cannot use S3 to store user data.
Yes, you can.
No, you can't.
Yes, you can.
Okay, stop. Stop.
Yes.
Let me
The September 1 law in Germany, the new privacy law,
No, it's not the new one.
has the definition of a data processor where or not, yes or no, you can use that. And so with S3, you can use it as a data processor.
I'm thinking about a very specific policy where in Germany, if I'm asking somebody to delete all my data, he needs to be able to prove that everything is deleted. If it's somewhere in the cloud, stored somewhere in S3 on some data center that the US government has access to at any time.
No, that's not true. As you know, and at least Amazon does, I don't know whether it's for the other guys, we comply with safe harbor rules, which means that if you follow the data protection the directorate of the EU, yeah, we follow safe harbor rules. There's an explicit number of lists of things that you have to do when the government comes to you and asks for access to this data, which is to notify you, to give you the ability to retrieve your data or to remove your data before other ones get access. There's very explicit rules around this.
Werner, the rest of us agree against you in the sense that we're open source. So anyone can host our application, right? So
but they still have to host it.
Yeah, we'd love to use you for your virtual private server, but
no, I'm more than happy that you guys run Cassandra and Mongo and others on Amazon EC2, which you can do with VBS, and tons of people do these kind of things. Yet you're wasting your time because that's not what you should be doing. You should be building better value for your customers, and it is by not focusing on your database.
That's what we're doing with the local databases. We're giving, like, take Salesforce as an example. Everybody who's using Salesforce is making a lot of money. If Salesforce goes down, an entire industry is unable to use stuff. If you have an offline version of Salesforce that would, for example, use...
How often did Salesforce go down?
Oh, it does happen. And Salesforce, sorry, Salesforce doesn't even have to go down for that. You need to have a connection to Salesforce. And again, if your cable provider, your DSL provider craps out, who's a happy Comcast customer? Exactly.
So are you arguing that Amazon should allow you to download the entire Amazon database and then shop locally?
It should allow users
and buy things locally?
Yes.
Yes.
Well, okay.
Can I hack it on the plane? I guess that's a question. When the flight back from South by Southwest, can I hack the application?
Exactly.
But another question. So, we go back to the 7 biggest sites things for a moment. I hear NoSQL often, and the popular blog post a couple of weeks ago talking about how MySQL can scale and the NoSQL lie and all of this stuff. But we're kind of like in what we were with Web 2.0 a few years ago, where we have this term out here that we haven't really defined. How many people think NoSQL means big and scaling? Right? How many people think non-relational schemaless? Right? A few more hands, and I think that's a distinction that we've got to put some sort of definition to this term NoSQL so that we can, when we have Smackdowns like this, we can agree what we're arguing about.
All right. I think NoSQL is about choice of data storage, which Werner says we're wasting our time on. But if I'm building an application that needs very fast logging, I'm looking at Memcache at Redis and MongoDB. If I need something that has offline peer-to-peer replication, I'm looking at CouchDB. If I'm looking at something that needs to be hosted and I shouldn't think about it, I look at S3 and the other stuff Amazon and other people are doing. If I have hundreds and thousands of servers that I need to keep busy, I look at Hadoop or Cassandra.
Well, I would like to point out that this is a big data meetup. And SimpleDB, I think, has a 10 gigabyte limit?
Per domain.
Per domain. Well, okay.
So basically what you have to do is you have to do your own partitioning.
Right.
I'm not saying that
do your own partitioning.
Okay, so let me... So when I think about NoSQL, and given that we have some history in this, or what I think before SQL was that for a very long time the database, any data storage, and whether it was a database or whether it was just storage, the default application to use there, or the default service to use there, was a relational database, because there was nothing else. Maybe you can have some BDB, but I mean, those are basically the only two choices. Now, what drove us to start building different types of databases is because if you look closer at how your processing is, and you can decompose processing into different steps. You see that for most of those different steps, you have different data storage requirements. And that for each of those different requirements, you can find a very dedicated solution that is capable of being very fast, very reliable, while doing the generic thing, throwing all requirements into one big bucket. You end up with something, actually technology that has been developed in the 80s, where we expect to have 21st century scaling and performance out of. That's impossible. Yeah? And so that was the thing that drives it. And if I look at the things that Amazon offers, it's not necessarily that I think that SimpleDB is the one and only table solution. No, it's a bucket of tools that you get these days. You have S3, you have SimpleDB, you have, maybe you want to run your own, you want some WAN caching. But the most important is that we now have a whole range of solutions where people can pick from.
So you said impossible. I wouldn't say impossible. I would say just not discovered yet. I mean, you can't. For relational, well, there are ways to implement things that are somewhat relational on top of these stores.
But not without breaking the model. Yeah. So, for example, if you want to do implement everything like inner transactions, like multi-level views, and all of these kind of things,
absolutely,
without breaking existing application, you cannot. So this is, if we could have built an absolutely infinite scalable relational database and kept all of the running programs intact, we would have done it.
Right, absolutely. And CAP theorem, I assure everyone has heard of it. CAP theorem, we all agree. I don't think any of us have transactions, so I mean, we'll skip right over that, right? Well, except, so now SimpleDB has transactions. No? Atomic gets and puts, isn't it?
No. You have conditional
conditional, okay.
Which are actually in the line with eventual consistency. Yeah. Here, you actually, if you cannot figure out the consistency model, you ask the system to do this for you. Yeah. And remember, under the covers, SimpleDB is still an eventual consistent system. It is just that there's a number of operations on top of that with a different failure model. Yeah. That you can use both.
Let's talk data size real briefly. I'd just like to point out that we have users of Cassandra that are storing multiple terabytes of data per node. So,
how many?
How do you guys respond to that?
How many users are doing that?
We have at least 3 or 4. Twitter and Dig and Reddit are probably all using multiple, gigabytes. Facebook.
We've got a couple of these, Meebo and the BBC, one of the biggest ones, that do multi-terabyte sizes. Maybe not on a single box. CouchDB definitely supports that, but these guys haven't run into they are in one of the 7 biggest, so they're not there yet.
So how many of those sites started on a system of that scale? And would we have them today if they had?
If they had seen the future, they probably would have started on Cassandra.
Oh, magic.
But I don't know. We like to believe that it's only the big sites that have big data. But think about anybody that builds a Facebook game these days. Yeah. That means that you can go from 0 to 25 million users in a month.
Yeah, startups are about optimism.
And so imagine all the logging you need to do, all the objects you need to keep around, all these things you need to do. Running into petabytes of data is something that you do very, very, very quickly these days. Yeah? You run a marketing campaign on the web. A marketing campaign is no longer just a website. It's a website, it's video, it's user-contributed content, it's casual gaming, it is integration into social networks, all of these things. That's a modern marketing campaign. All the data that those things generate, you're talking about terabytes of data quickly.
That's a good point. So let's talk about some of the use cases, the scenarios that you would need in most applications that do just that thing. Can you, a Cassandra or Couch, and I don't know the answer to this, update documents partially? Do I have to get the whole document before I can update it? Or is there positional updates and incrementals and things? Okay. Are those new?
No, it's been in for a while.
Okay.
And yeah, Cassandra can. I mean, we can have very, very large rows, so obviously you're not pushing the whole row at once. People can just insert more things. People build indexes within a single row for the rest of their data.
What sort of operators are built in to do that for you automatically, to do things like incrementing a value, adding something to an array, updating a key in a hash?
Let me call you Bob for a second. You write a JavaScript function for that.
Yeah, I mean, exactly. I can drop down and do that in Mongo too, but I mean, there's convenience is what I'm putting at.
Like we have a very small set of a standard library for these functions, but users have not asked for that a whole lot. So it is expandable, of course, but we don't have a lot of that yet.
Okay, so let me ask you guys another question. Right. So you're open source. So if you put out a new release, do your customers have to take your database down?
No.
No. So explain how you do it.
Well, so what do you expect? So CouchDB has a very robust file format, and everything since the last 3 versions uses the same file format, so you don't have to do any upgrades. So the server can deal with the same thing that you're actually doing. So CouchDB has a very robust file system storage model that has been stable for a couple of versions. So whenever you upgrade, you never have to change anything without with your existing setup. On top of that, CouchDB is built in Erlang. Who's a fan of Erlang here? Woohoo! Erlang has the capacity, has a feature that allows you to upgrade a version at runtime, so it can run 2 versions at the same time while serving a database without having to take it down. So it has live upgrades built in.
So Cassandra, I mean, we're changing the file format soon. You will have to restart the cluster. I mean, saying that you'll never have to change the file format is kind of, you know.
So what happens then if you have 10,000 nodes running?
You can do a rolling restart.
Yeah?
That's the plan.
And how long does this rolling restart take? Just from a practical point of view, we've done these things a few times. But
I mean, what else do operations folks have to do? I mean, it's fun. No, I'm kidding. Honestly,
so this is one more case why you should not be worried about this stuff. You know, use this storage as a service, man. This is old-fashioned. This is so 1990s.
I disagree. So with Cassandra, you can run a single node incredibly easy. You can get a second node started incredibly easy. They can be anywhere. They're data center, locality aware. But I mean, we have 45 node installs. Twitter is running on 45 nodes. But yeah, Facebook had 150. It's easy enough to grow your cluster that I think it may be more difficult to use EC2 than it is to manage your Cassandra cluster.
I'd like to tag in Jay Chris from the CouchDB project, who's got a few things to say.
Sorry about that. I'm breaking the rules, but I just wanted to bring the debate up a notch. So all this they've been talking about, as far as I'm concerned, this is geek stuff. I don't care. I'm a developer. I write Erlang, but you shouldn't have to worry about any of this. Your database is yours. It lives at the edge. It's your data. Replication means any copy of the data. You can move it around. You can build workflows on top of replication. None of these guys, they're all zigging. We're zagging. So I would like to see some people talking about the use case. I want to share photos with grandma, and I don't want to ask Mark Zuckerberg for any favors.
Stuff it in S3 because then you get URLs that are just completely addressable from the web. You don't need any intermediary servers. Key value, just web addressable stuff. That's the way to go.
Does grandma know how to use curl? I mean, I don't know. I assume you're going to develop an app for her. But next up, so in terms of performance, I don't even know if we need to talk about it because I think Cassandra has you guys topped.
So CouchDB doesn't optimize for single query performance, so everything might just be fast enough, not as fast as it can get, but by the properties that Erlang systems come with, it can handle thousands and 10,000, maybe 100,000 concurrent connections and have a constant stream of performance out of whatever your hardware supports without falling over.
I would argue Mongo's fast enough. I mean, Cassandra's got to
you don't have a concurrency story. Like, what if 1,000 users hit you at the same time? You're dead in the water again.
There's caching.
They're written in C. I mean, that's a good, right? Aren't they fast enough?
It doesn't scale concurrently.
So how easy is it to also quickly hook up a CDN to your store? Can you just with one flip of the bit suddenly have caching all over the world and
Not
things
open
live
source.
very loaded? No. So what is it? S3 doing 125,000 transactions a second?
So Cassandra can do 25,000 requests per second per node.
Do we have more audience questions before that?
All right. Talk about transactions. Do you need transactions? Banks have relational databases because they have transactions. So you're going to have entities that need transactions. That's why there'll always be relational databases.
Yeah, I'll repeat the question. He's asking about transactions. Do people need transactions? Raise your hands. Okay, so that's your answer.
Okay, so
Oh, wait. First of all, transactions have nothing to do with relational databases. The fact that they were offered by the same particular tool, that's a different thing. Yeah? Transactions is just that you get a number of guarantees, asset guarantees about the update of your data. That's all. It have nothing to do with relational databases.
Also, NoSQL is about using the right tool for the job.
Yeah.
Exactly. So there are engines for building transactions. Zookeeper is one of them. It's open source as well. That's how you should do your transactions, and that's how a lot of people do. So let's talk a little about ecosystems. Cassandra, I'm going to name drop. Cassandra has a few good installs. Twitter, CloudKick, alphabetically. CloudKick is at the top. But yes, also Twitter, Facebook. What do you guys got?
I got the BBC. I got Canonical. It's not as big as you can get, but we probably have a few more installs than you guys have.
It's been a while since I've been out to the list. I know Discuss is out there. SourceForge moved to MongoDB. Of course, tail.thechangelog.com is how you keep up with open source software.
Someone made a remark, someone tweeted a remark saying that when S3 is down, I tell you to go to the bar. That was a joke. Before someone thinks that is an official company statement. I think just with any other database or whatever, you protect yourself at multiple different levels. You use caching, you be intelligent about where you store your data. S3 also gives you multiple zones and availability zones where you can actually store your data. There's many techniques that you can use to protect yourself from these kind of failures. Just that's the real answer I should have given. I thought the other one's funnier.
So how about wide area replication? I mean, people are geographically distributed. Cassandra supports wide area replication. It's kind of native. How do people accomplish that with your stores, or do they fall down?
CouchDB has master or multi-master replication built in, which has been built for geographical distribution in mind. So we just have that.
I believe currently Mongo is master-slave, but I believe master-master is coming.
Yeah, but it never works with your data model.
Multiple regions, where each of the regions is guaranteed to store the data independently. Store your data in the EU. It's guaranteed to only stay in the EU, and not even metadata about the data will ever leave the EU. So you get geographical replication for free. The East Coast disappears off the Earth, which actually appears to be happening at the moment. You'll still have the other sides, and you still have Asia and things like that as well.
Yeah, so Bigtable recently had an outage. I guess it was App Engine, and I love Google because they're very, very open about what went down. Amazon is too. But so what went down was that their master and slave replication basically got out of sync between data centers. So I don't know how I feel about master slave replication. Can we break that? Is Mongo planning to break that?
Good question.
Good question. Yeah, you can break it. It's not that hard to break it, but there's advantages on all sides. As always, the cap theorem is not that it forces us to use a particular consistency model. You get to make the trade-offs. I think Cassandra as well as Dynamo before that. One of the exercises in Dynamo was really to make sure that we would give in the hands of the developers the choice to go for, do you want to be really highly available, or are you willing to sacrifice some of your consistency model there? And there's knobs which you can use there. Plus, I think but the biggest innovation in all of this was something called sloppy quorum. The fact that you could take writes even if your quorum is down, and you could always write to the system. Here, you have a customer that wants to put something in his shopping cart. You're going to tell him, no, the storage system failed, timed out. No, it just always works.
I don't actually have a response to that. I guess that's possible in CouchDB,
yeah,
but only because no node actually knows whether it's responsible for something. But I think we had a question.
I think the one question you really need to answer with NoSQL is, why do I want to do this instead of just staying with MySQL and buying a bigger machine? I can buy a 10 terabyte RAM, 500 core machine that will run MySQL or Oracle or whatever just fine. Why do I want a NoSQL?
So the question was, why not just scale up? Why scale out? I would say that the answer when it comes to Oracle is price. That's very, very clear. We're all open source. And when it comes to MySQL, eventually that machine goes down, and you have some sloppy situation where you have to either use patches to MySQL to not lose your data, or you have to implement something else. You have your ops team implement DRVD or something.
You know, it's back to the big data versus the schemaless question. And I think if you're comparing something like Mongo to MySQL, I think it's a more fair comparison because it's you mentioned highly available. I would mention highly productive, right? So a lot of applications now, let's face it, a lot of the data that you use, you're not creating in-house. You're consuming APIs from other places, and a lot of that is coming from JSON. It's coming from other hashes that are up in the sky, right? Using something like MySQL, then you have to model that schema and stash those. Using a NoSQL store, you can just stash the hash.
So in answer to that question, when I see somebody writing a Ruby app or a Java app or anything with a middle tier application layer, I look at that as a huge waste of time. With Couch Apps, it's just the browser and the CouchDB, right? You got a jQuery guy and you got somebody who knows how to keep the server from dying. That's all it takes. And you know, Werner's on that same case. He's got HTTP. I agree with that. Just having an HTTP-based database means that you don't need all that crap in the middle.
Well, I was actually arguing that you have to have a range of things to be able to pick from, and one of them is an HTTP accessible. But coming back to your question, actually, I think there's a number of use cases, and especially where it goes about existing software where you still may want to run your relational database. Now, when we built the first services at Amazon Storage Services, we did not offer a relational storage service. Why not? Because we thought that, you know, that would send the wrong signal because you really want to build scalable apps. You don't do that. However, there's a ton of applications. If you use Ruby and you use Active Records, you know, or any standard ORM kind of tool, you know, they all want to talk to MySQL. And so here you have a whole range of developers that just want to focus on writing Ruby. They don't want to run databases or whatever, and they don't care about what the backend is. And that's your argument about very small databases, very small data sets. You don't care. As soon as you have to scale, as soon as reliability becomes an issue, all of these kind of things, then it turns out that relational databases have their limitations at points that, you know, will hurt you.
You bring up an excellent point about Active Record. I don't want to bitch about it. It's really, really cool for what it does. But it is a thing of simplicity. CouchDB is built with simplicity in mind. And the thing that we have in the store here is that Active Record, the last time I looked, had around 25,000 lines of Ruby code. And I know this is apples and whatever bungalows in a comparison. CouchDB comes at around 15,000 lines of code. So our entire database is smaller than the wrapper you're using to solve your programming issues. So we compress the stack by using pure Couch Apps without ORMs, without all the middleware crap that you could like find bugs in that takes a long time to use. Like, it's just boring and slow, and I don't know. It plain sucks. I'm sorry.
You know, I welcome this renaissance we got for JavaScript and all these new NoSQL databases that are embracing this language of the past. But the problem of Couch is the fact that you have to do everything in
Talk
JavaScript.
to Apple, Google, and Mozilla about a language of the past.
I'm a JavaScript fanboy. You listen to the changelog. We mention Node.js on every episode. But the problem with Couch is you have to drop down to MapReduce in JavaScript to do anything. Anything of consequence, you have to drop down to JavaScript. And, you know, I'm familiar with JavaScript. I love JavaScript, but I know a lot of the folks that I work with feel like you have to have hazmat gloves to touch JavaScript.
Yeah, that's cool, but they're like the CS majors of everybody. People who tinker with the web designers who just start to use jQuery, they're comfortable with that. They can use CouchDB.
You're going to get a web designer and a Couch database?
Yes.
Oh, okay, this I got to see.
And his name is Bob. But, so guys, we have to start wrapping up. Is it a quick one?
Yeah, it's about data modeling. A lot of people who do relational databases always think about their data models. I just have the impression when you talk about these NoSQL databases that you just set data modeling at the side and you don't think about how you...
So the question was about data models, and there are names for what we do. In a relational database, you typically want to normalize, and in a non-relational database, you want to denormalize, and it's really just that simple. So you duplicate, but that's fine, is what we say. So, in closing statements, let's just talk about what you would use if you couldn't use your own product. So you would you're implementing something, it's going to be a perfect fit for CouchDB, but your manager says, no, you can't use CouchDB. So, what's your next choice?
I think I'd probably use Preservere, which is actually written in JavaScript, so there you go.
Cool, so
Because it's written in JavaScript and all the other languages are boring.
But does it scale? So if I couldn't use Cassandra, I'd have to say React's really interesting, but the kind of closed source project they have going on, and Voldemort's interesting too, but they don't have ordered keys, and I love ordered keys. But yeah, so maybe React, maybe Couch.
If I couldn't use Mongo, perhaps Couch, but it depends on the scenario. If we need to do dynamic queries or something like that. That was just a pain point for a lot of several apps that we went through. I would like to probably check out Redis or some of the other systems that probably should have been up here. And let me just say that I hope I didn't deter anybody from using MongoDB. I'm just a fanboy, like I said. I wish somebody from Tengen could have been here to adequately represent the database. It's a cool database.
Actually, I think the one database that was left out, which I think is very different from this one, is Neo4j. Yeah, I think that's if you look at databases that build things for a very specific domain, where you have graphs, where actually all your data is structured as graphs. Take any social network or anything with multiple relationships and multiple connections. Neo4j is absolutely rocks. In that sense, I don't think they deserve. However, partitioning that is a pretty hard thing
exactly,
to do.
Yeah. Partitioning a graph, it's a computer science problem, but it's not solved.
No. So hey, why don't we build one? Yeah.
Exactly.
So
cool.
if I can't use, I don't know, I'll go to a bar for a few hours and I'll come back and then people will say I can use S3 again.
All right, so we're cooling down. Any other questions, guys?
If not, guys, let's all say thank you, the non-relational database Smackdown. All right, great. You can all collect your winnings in the bank. Now, I think the next phase of the evening, the event is supposed to go on until about 9 o'clock, guys. But if you want to hang out beyond that and just keep talking and drinking, I'm sure Opal Divines will love it, and so will we. But in the interim, let's break down into these sessions for specific sorts of approaches to dealing with data. With managing data, we've got an operations talk led by Harper Reed from Rackspace. That's going to be over there in the Rackspace room where you guys all ate dinner. We've also got an exploring data talk that's talking about analytics. And that's going to be led by Toby Jungen from Swingly, as well as Steve Watt from IBM. That's going to be on the far side of the deck, guys. So get as close and dangerously close to the rail as you can get. After that, we've got seeing data. This is visualizations with Amber Case and Valdes Krebs. That's going to be on this side of the deck, right here where I'm speaking. We've also got humanizing data. This is how to build web apps that use data to do amazing things. And that's going to be with Joe West from No More. That's right in the middle between visualizing and analytics on the other side. And then finally, we've got myself from InfoChimps and Gil Elbaz from Factual talking about open data and monetization methods over here in the bar. I recommend that.